Hello and welcome to Mertech's 10th Campfire. Hope you're all doing okay. I think we had a lot more signups, especially from Brazil, but I doubt they're going to be attending today because of the World Cup starting. Um, I'd like to introduce you to Oliver Nelson. He's our senior technologist, and you're familiar with him presenting our webinars for the past 10 sessions. Today's topic is security in web applications. As we are moving more towards a cloud-based technology stack, where we're no longer Windows desktop centric, more and more application developers are looking to redevelop their applications for the web to offer their applications as a software as a service, or companies are moving their applications so they're easily supported. Device is no longer just the desktop. You have tablets, you have phones, etc. So one of the most often overlooked aspect of application development is security. When you are in a Windows application environment in a network, security is kind of secondary in there. There are some security, user ID, password, some encryption, and that's about it. But the web poses a special challenge, and it's very important that developers who are going to develop applications for the web how to protect their applications and develop their applications so it's more secure for the web and in the cloud. So today's topic is about that. We want to explore some of these areas that we have come across. We share some of the experiences we have had. I would like to hear your experiences, and through the process, we'll learn and teach each other something. So Oliver, take over.
Okay, so we're going to really talk about four main areas of web security, and these are SSL, passwords, session contamination, and SQL injection, and we'll touch on a couple other topics along the way. Now, normally when we talk about SSL, essentially what I've told people in the past is use it. Have your entire site encrypted. But recently, month and a half ago, SSL turned into a special topic because of Heartbleed. Now, Heartbleed isn't a bug that necessarily affected a lot of Dataflex-based web applications because of, or in fact anything based on IIS, because of the fact that Heartbleed was an open SSL-based bug. But there's a specific reason I wanted to go through the Heartbleed bug just a little bit to start with here. So just to give you a brief overview, Heartbleed was an exploit that basically had a few areas where it really could cause you some grief. Essentially, it was a bug that caused a heartbeat request that's part of the SSL specification, a malformed heartbeat request. You could send essentially what was a 1-byte request, and due to a programming oversight, it would actually, instead of returning back the 1 byte that you sent, which is what the heartbeat was supposed to do, it would return back 64 kilobytes minus 1 byte of system RAM. And the section of RAM that was returned was somewhat random based on where that 1 byte had been allocated to by the process. And so people were able to send these malformed requests, and essentially they were able to, over a period of time, collect a whole bunch of whatever was loaded in RAM. This could be, and was often, the private keys that your SSL certificate was encrypted against. Could be usernames that were loaded into memory, passwords that were loaded into memory, documents maybe that had been sent via, uploaded onto the web or downloaded. And the really killer part about Heartbleed is that it didn't leave behind any evidence that anything had occurred at all. So there was no log of what had been taken. And so, of course, although you may not have been directly affected by Heartbleed on an IIS server, certainly many of us were indirectly affected by it, being asked to change passwords on very common websites like eBay. The number of websites affected by this was something like 17% of all websites. It was a pretty high percentage, and of course, this caused reissuing of SSL certificates along with changing of user passwords because no one knew exactly what had gotten out. So essentially, they had to treat the situation as if everything had gotten out. So their private keys, all the users' passwords, everything like that. Now, the reason I wanted to mention Heartbleed here specifically is because a lot of times when developers create a website and turn SSL on, they have usernames and passwords, it creates a false sense of security. They will essentially think that because they've got this turned on, this underlying layer is taking care of things for them. But in fact, it's not. There are many other steps that you need to regularly take, and bloods like Heartbleed really show this. So next we're going to talk about how to deal with one of those areas, which is passwords.
I'll call them here.
So when we talk about passwords, there are a few things to discuss here. Of course, we all know that passwords are kind of one of those topics that that can wrangle people because of the fact that users come up with crummy passwords. And so when we talk about passwords, we also have to talk about the problems that are associated with them rather than just saying use passwords or anything like that. We know that passwords are often reused by users, so if they have a certain password for their iTunes account, let's say, or for their PayPal account, that password very often is also used in your system, no matter what that may happen to be. And so there's some issues related to that. Password requirements also can be very confusing. You've certainly come across sites where they made you register and the password had to have at least one of 5 different classes of characters, uppercase, numeric, all of these various things. And the problem really arises in relation to this. What happens on websites, whether or not, let's say you have a service that you're offering that is not financially related at all. It's just maybe it's something for the World Cup, or maybe you've got some application where users can chat with each other, or whatever the case may be. And so you view the passwords that you have in your system as not being really that critical. There's no financial data they can get to. But with things like difficult password requirements and the fact that users use crummy passwords to begin with and reuse passwords, what you need to understand is that the password is actually the data. When someone is trying to get at your passwords, when someone's trying to break into your database and get to that sort of information, in general, if you don't have an application that has any financial tie-ins, credit card access, things like that, what they're looking for is email addresses, usernames, and passwords so that they can go and use those on other sites that do have access to people's credit card numbers and things like that. So in fact, when we talk about protecting passwords, even if your website doesn't do anything critical, the password is the data to protect in most cases. You have another layer of responsibility in place if you are storing credit card data and things like that. And we're not really going to get into that, but if it is just a username and password, that's what people are going to try and steal from your database. And the fact is that you are liable for that. That's something that you're responsible for protecting, and it really has ramifications related to your business. They sell insurance for this sort of stuff. So how do you deal with passwords safely in your web application? So there are a few things you can do, and this first one is probably the one that you'll catch the most heat on. okay, because I just said that password requirements are crazy. But when we're looking at a password that has some longevity to it, that isn't going to be broken in a period of what hardware is going to increase to in the next couple of years, the advice right now is 11 characters minimum, with a mixture of character classes in there. That's a long password. I mean, I admit that's a long password, but when we're talking about being able to actually protect that password, that's really the amount of data that's needed in the password to make it very difficult to break. Now, one of the things that I don't advocate is regularly changing passwords. So, of course, we've all had many sites that do this, that make us change our passwords all the time. But in fact, in general, that actually reduces the security of a web application. You can look up, there's quite a few studies that have gone into this area, and for a long time it was thought that regular password changes were the way to go. And of course, there's even some stuff related to banking requirements that force them to change their passwords regularly. But in general, what happens when you force a user to change their password regularly is they start to use worse and worse passwords or reuse passwords. And so essentially you are lowering the quality of the passwords. Unless, of course, your users are doing something like using a random password generator. Some of the browsers have some of that built in now. But in general, I advise against that. There's this article definitely that I send people to as well on GRC, Gibson Research Center, called Haystack. And this document is one I advise everyone to read. It kind of goes through the concepts behind passwords from beginning to end. And it's much more extensive than I could ever get in a presentation like this, but it's a great document to take a look at and to kind of get your head around. The next item here is to have a sane password reset policy. A lot of times the password reset policies, we've seen exploits related to password reset policies where, especially if there is financial data involved, where they'll use some digits of the credit card to help in resetting passwords or things like that. Password reset policies should really, ideally you want them based around the concept of sending out a reset email, if at all possible, with limits on how long that temporary password is available and things like that. But now to get into the real important items related to passwords, we never want to store passwords in our databases. What we want to do is we want to store hashes in our database, and we're going to talk about this in a little bit more detail in a moment here. But when we talk about hashes, classically you've seen a lot of applications using things like an MD5 hash or an SHA-1 hash. And in general, this is a very bad idea. The reason is that these hashes they have a very low cost for calculation to them. And so essentially what happens is that the hash is, one, it's not necessarily unique across a very large address space, so you can come up with some other text that hashes to the same thing, which can let someone into a system. And secondly, it's not computationally intensive to calculate the hash. When we talk about these hashes here, PBK, DF2, bcrypt, scrypt, these are specially formed hash algorithms intended for passwords that essentially use a lot of processor power to calculate a hash on a password. And the reason this is beneficial is that it increases the actual cost of someone decrypting that, or figuring out, not decrypting, but essentially figuring out what that hash is, because it's very computationally intensive. So the hardware that's required can get very expensive to break a hash in any decent amount of time, and the electrical costs associated with calculating all of those hashes can be high. So by using hash algorithms that have high work factors, essentially you're increasing the cost of breaking each individual hash. Now the last item here, use salts. We're going to go over that in the next slide here. So let's just kind of go forward to this here and take a look at how you might safely handle passwords in your application. So we have here a very poor password, one of the most common passwords there is, let me in. And so how can that password be made any more secure? Well, what we do here is instead of storing the password in the database, we have two fields in our users table in this case. We have a salt field and we have a hash field. What we do when we hash something is, in the case of a salted hash, is we generate a salt which is unique to each and every user account. It used to be that a lot of times systems would use a single salt for all user passwords, but if someone is, the risk associated with this, if someone's able to get hold of your database, are they able to get to all of your passwords? If you're using a common salt for every row, if they can do some analysis on the database and figure out using statistical analysis what some of the passwords will be if users had a common password, because they would have hashed to the same value. So the idea behind a hash is that we take a value, we run an algorithm on it, and it spits out something that cannot be reversed back to the password. It's a one-way algorithm on this data that generates a certain size of a hash, in this case a 256-bit hash. And this hash will, basically this password will always hash to the same value. But by storing the hash in our database, a user can enter their password, and when they go to log in, we take the password and the salt that we have stored in the database for that user, which we randomly generate. We put the two together, and then we run the hashing algorithm on it, and we see if it hashes to the same thing we have stored in our database. And now, essentially, we've verified that the user has entered the correct password, even though we're not storing that password. That's our basic idea behind a hash. When you use these, you got to make sure that each record gets its own salt. Each user gets their own salt, so that if someone does get hold of your database, even if you have, let's say you had 100,000 users and maybe 500 of those users used the same password. That's a very, very high possibility, by the way, that you would see something like that. By having a separate salt for each and every user, they will not be able, the person who gets hold of your database won't be able to use any sort of statistical analysis to find common passwords based on the number of identical hashes in your database. So it's just one more protection that makes it significantly more difficult for someone to essentially get to these passwords eventually. Now, that doesn't mean that they can't take some of the common passwords. As you can see, there were very few requirements for this password here. We've got one class of character here that they couldn't take, the top 100 passwords and go through every account in your database and use the salt that you have and generate the hash and see if they get any hits. Certainly they can do that, but this reduces the number of those that they're going to be able to get. So it reduces your possible liability in relation to them. The actual number of compromised accounts can go down. So why do we do it this way? Well, like I said, we never want to store passwords in our database. This gives us a way of not storing them there. Second, it resists the statistical analysis attacks we talked about. It also resists standard rainbow table attacks. So when we talk about statistical analysis and rainbow table attacks, there's a couple of things here. One, there's the statistical analysis of the entire database. which is what I mentioned before. But there's also this this concept related to being able to essentially brute force a password, but to make your brute forcing would be where you try every possible combination, that fits within your password requirements. But there's some weaknesses related to brute force attacks using statistical analysis that it can actually recover a huge percentage of passwords. What people do if they want to break passwords that are somewhat well protected is they use something called Markov chains. Markov chains basically are a statistical tool that allow you to look for patterns in passwords that are commonly used, and to essentially reduce the address space that you have to analyze in a brute force attack to basically reduce the amount of time it takes to break a password. So for instance, I would imagine maybe some of you have a password that begins with an uppercase letter, has some lowercase letters in it, and then ends with a number and a symbol. Or maybe you have a password that begins with a number or a few numbers and then ends with some letters. These are very common patterns for passwords, and by using those patterns and looking for passwords that match those patterns, we can find passwords that look fairly random, but in fact are not random at all, and they can reduce this address space. So that's one of the reasons that long passwords are essential nowadays, is because it makes these sort of Markov chain attacks very difficult as well. The last item here about providing single password protection, that's really related to individually salting passwords so that each individual password has the same amount of actual computational requirements to break as every other password in the database. Without doing things like that, the computational requirements for each additional password go down significantly. So salting is very important as well. So the takeaway from this is that SSL does provide some protection, but when we're talking about passwords, there are lots of things you have to do on your own as well. You have to make sure you're salting your passwords individually. You have to make sure you are not storing, salting your user accounts individually, that you're not storing passwords, that you're storing hashes. One of the things I commonly look for when I go to sign up for an account somewhere or something like that is what are their password requirements? You probably have seen password requirements where they say things like, this password has to be between 8 and 16 characters long, for instance. That's normally a bad sign. Normally that indicates that they are actually storing a password or an encrypted form of the password or something like that. When you're using a hashing algorithm, a password could be multiple sentences long. It could be as long as you're reasonably allowed to take, and it's always going to hash to that same 256 bits. So in general, sites that have that are using a properly hashed password system, they either aren't going to have any password length requirement, or they'll have a minimum only, or they'll have a very high maximum. A lot of times they won't even mention it. So that's one of the things I look for also. So our next topic that we're going to talk about is session contamination. So session contamination is specifically, we're going to be talking about session contamination in relation to Dataflex-based web applications. And session contamination is the idea that something is left behind or is in an improper state between different users accessing a service. So we've got some general items to stay away from here, and I'll mention these again later. But let's take a look at an example. We're actually going to look at some source code here. of a function that has a session contamination bug in it. So do something critical is our function that we're publishing here. It takes some parameter and returns this t-struct, whatever. We go through here, we find in our table if based on the user, if the user's found and we have a hash match, then we set it to authorized. If that user shows that they're an admin, we set our admin property to true. And otherwise, we set admin to false and authorized to false. If we're authorized, we do something, and if they're an admin, we do some other something. Pretty simple function. But there's a subtle bug in this function. The bug's right here. One of the things you want to avoid in web applications is the use of properties. As you can see, I'm using a couple of properties here, and it's not that properties can't be used for some reason, but you have to be very careful with their use. In this case, I'm using a property improperly. So what we have here is a situation where let's imagine two users coming in and accessing this service, and of course we're in a pooled environment, process pooled environment, so they're going to be accessing very possibly the exact same process as each other, one after the other. So the first user comes in, enters their username, password, and so we come here and we do our hash check on it, and they're authorized, and lo and behold, this user is an admin. So we set this admin property to true. And then we go down into our code and we do something and load the admin stuff and return a structure to the client. And that's essentially what this function does. Then our second user comes in. Well, our second user comes in and authorized right now is true. But, you know, if they're not authorized, we set it to false. And admin is true. So this user comes in and we do a find on the account. And sure enough, it's found, and so authorized is set true. Well, it was already set true from the last request that we had. But this user isn't an admin, so we don't do that next line. And then we continue on with our code. Do you see the issue here? Although I'm setting admin to true, if the user is not an admin, I'm never setting it to false to take admin rights away for this second request. Now, I'm setting it to false down below there. If they're not authorized, I reset it there. But I'm not resetting it in this case. This is the sort of subtle bug that occurs in a session contamination environment. And it's the sort of reason why we avoid using properties in web applications, if at all possible. Essentially, if we go back here, you'll see that there are a few things we should avoid. One, the use of properties. Second, the use of global variables, which essentially have the exact same risk associated with them. This third item is very important. The way we avoid session contamination is really to treat each and every function as if it is a new state machine. So if we have various items in our function that depend on the state of various other items, the beginning of each function begins with something that essentially resets all of those variables, properties, if we have to use them. It resets everything to in this case, to a not authorized denied state. So we always fail to a denied state. So everything will get reset in that fashion. And so instead of having a function structured in this fashion, we may have something at the beginning of the function that essentially just goes through and resets everything. And that's one of the ways that we avoid this. One of the other areas that can pop up in session contamination, it's a little complex to show, so I don't have an example of it here, but is in relation to storing state information. So when you're storing state information, you have to remember that you can never trust the client. You can never trust anything coming from a web client to be in any way safe because it doesn't necessarily have to come from your application at all. So essentially anything related to state, especially if that state is allows forward progress in the application or anything like that, should be stored on the server and loaded into essentially this state machine at the beginning of each and every function. You should never store state that has any value to it on the client side and pass that over to the server, even though a lot of times that's more convenient. Now you'll see people that sometimes will store state information in cookies, and that's that's a valid sort of thing. But in general, where they do that, they're storing things that are actually really not that important. Preferences, things like that, can be stored in a state in a cookie on the client without a problem, but anything important should be stored server-side. And the last item here is to make sure that your application uses logging. You'll notice this function doesn't have any logging in it at all, and that's a dead giveaway of a problem. You definitely want some sort of logging in here so that you can basically track what has occurred with client requests, and oftentimes it's good to have multiple levels of logging so that you can turn the logging up if you see some issues.
Oliver, I have a question for you.
Okay.
The the part where you set PVA admin the admin to true and not set the non-admin user to something else, how common is this in applications?
Well, we've seen it in just about every web application that we've worked on. If we've been contracted to do security reviews or things like that on applications, we see this all the time. It's very difficult to get this correct because if you've been developing Windows applications or you've been developing even web applications that are truly session-based, the idea of doing something that's stateless is really quite foreign, and it takes a little bit different thought process. So this is a risk we see all over the place, and it can be very complex to actually work your way through how a user got improper rights this way, because these are very subtle bugs.
And so what's the fix for this? Something in the code that you could do?
Essentially, what we try and do is, like I said, have essentially a reset sort of function that's called at the beginning of every function. So you'll have some other internal function that resets things, and of course we try not to use properties. The question is, how do you avoid using properties? One of the ways that we avoid using properties is by using some sort of ephemeral storage, or a storage that is only valid for a specific call. Now, web app doesn't have anything like that built in. We've built some things for ourselves that allow that sort of ephemeral storage. But essentially that's what you need. You need some area that you can store state in that is thrown away at the end of each and every function call. So like I said, it can be pretty difficult to get this right, but it's certainly something to watch for. This is something that probably many of you have in your code and just haven't seen yet, or haven't been able to track down. So the next item we're going to run into here is SQL injection. So SQL injection, if you're not familiar with it, is basically the idea that in your application you are doing SQL calls and some data gets passed in from an untrusted source, and that data changes the way the SQL call actually executes. And essentially the takeaway is to sanitize everything. There are a few ways of dealing with it, but let's take a look at an actual SQL injection call. Because a lot of times this is something that you haven't seen. And by the way, for DataFlex developers, SQL injection calls haven't been a big risk. It's not something DataFlex developers have had to worry about much. The reason they haven't had to worry about it is, of course, that with the data dictionary, all of that doesn't really exist. We don't have those sort of risks with our our Dataflex file buffers and with the data dictionary. So why am I discussing SQL injection? Well, the main reason is that as you extend your web applications, your Windows applications, and start to use a database server backend and optimize things for your users, one of the things that commonly happens is that if you have lists on the web, paged lists, things like that, instead of doing a loop to find all the records and sending those back to the client, users will optimize, or developers will optimize those into SQL calls to return a set of data, of course. And eventually, they either have right off the bat, or eventually they'll add filtering to that list, or there will be certain criteria that you can determine on that SQL call. And so all of a sudden, you can end up with a whole bunch of SQL in your Dataflex application. And since SQL injection isn't something the Dataflex developers think about much, these SQL injection attacks can easily occur. So let's take a look at, first, we're going to take a look at two different ones. A very simple one and then a little bit more complex one. So our basic SQL call here, select fields from table where field is value. Now, there are many ways that you can call this, but a lot of developers will just basically write a string of SQL, and they'll essentially fill values in that they get back from the client. And so what you end up with is you end up with something like this. So in this case, I've got just to select all columns from our customer table, and let's say that this is maybe a SaaS style application where you have customers for multiple companies. And so in this case, we've limited it to company ID of 1, 2, 3, 4, and that may be in your code where you're determining that from some other variable that you limit that company ID. And then we're also limiting it to customers that have a last name of Hill, and maybe that's the filter that a user has typed in. So this query is going to return, of course, customers with that company ID and the last name of Hill. What happens, though, if a user fills in something that we didn't expect in our SQL call? Well, this is where a SQL injection attack happens. So let's say that instead of filling in just Hill, we have the exact same situation, but the user fills in Hill and then a single quote, a space, or 1 equals 1 and then 2 dashes. What happens with this SQL call? Well, what we're essentially doing in this SQL call is we're saying that the customer can be 1, 2, 3, 4 and the last name of Hill, or we can return all the customers where 1 equals 1. Well, that's going to be all customers for all companies in your database. Just like that, just by changing the query string a little bit, what's typed in there, we're able to return all of this data that maybe falls outside of what they're allowed to see at all. Now, when we look at this query, you'll see those 2 dashes, and we're going to talk about those a little bit more and why those are there. But essentially, what we've done is we've changed the SQL query and put data into the SQL query that is actually executable, so to speak, rather than just a payload for values that are to be searched for in this case. So now let's look at a little bit more complex example. So this is a SQL call from an application that we've worked on, and this is just a monster of a SQL call. And very often, SQL calls can get like this real quickly. So we've got a join in here. We've got all of these I likes that are in here, and casting, and just all this stuff. And you would think, well, if someone types something invalid in there, it's just going to break the SQL call entirely. Our close quote or isn't going to work very well in a call like this because a lot of it just isn't valid. Well, let's take a look at what you could change this big old query to that still is going to cause some grief for you. So this is the same query. I had to make font a little smaller, but instead of having the value val passed in as what we're searching for in this case, the users typed in val, a closing quote, a semicolon, and then drop table invoices. That's how you get rid of a table in SQL entirely. So what would this call actually do? If you notice, there's still a closing quote at the end of that white section there, and there's a %sign. Is this even going to execute? Well, let's break this down and see what this SQL call actually ends up executing on the server. This is what we end up getting on the server. We end up with essentially 2 SQL calls and a comment. So our first one is just the value passed in, and we're going to do a SQL call for that. And it'll find all of those with an invoice number like val, and so it's probably not going to return anything. But then we have that semicolon there. Well, in SQL, of course, that's to end a statement, and you can have multiple statements in a SQL call very easily. And so what we're doing here is we're doing an entirely different statement. Drop table invoices, getting rid of the table. And so that's our next statement. And then how do we get rid of all the rest so that it just doesn't generate some error on the whole thing here? Those 2 dashes are how you indicate to SQL that everything else should be treated as a comment. So that's why a lot of times in these SQL calls you'll see these in SQL injection attacks, you'll see 2 dashes put in there. Now this is a call that was built for PostgreSQL, and but essentially everything else that was in our call there is just thrown away entirely now, and we've dropped our invoices table from a web client just doing a filter on a list. They didn't have to know much about it. There are SQL injection attacks where they can do things like get the name of the current table being queried so that they know to do drop table invoices. So they'll start with one call to get back invoices into the data set so they know that's the name of your table. And whereas the first example we showed was collecting data they shouldn't have seen, you can see this is a very destructive example. So how do you limit this? Well, right off the bat for this one of the things that I would advise right off the bat is to have user rights where dropping tables isn't allowed. All database backends allow you to control things like that based on the user that you're logged in as. So certainly preventing them from dropping a table is a very important aspect of your security system, limiting what that web user can do. Maybe that web user needs rights to delete, though, and this would still allow them to, generate delete SQL calls. In fact, I'm not going to show it here because this is going to, end up on our YouTube channel. But I've seen some SQL injection attacks that will do things just that are wrong. I mean, just really wrong. Like, for instance, delete 100 random records from the current table. If you have a large table, deleting 100 random records, you may not even notice it in time to deal with it from restoring from backup or anything like that standpoint. They may just be gone forever. So there are some really bad things that can be done this way. So that's why it's very, very important to sanitize your SQL. And there are a couple of things. There are parameterization that you can use or simple sanitization. So what does sanitizing this call look like? Well, in this case, essentially what we do is we run a sanitize function on all the data that's going to be embedded in the SQL call that comes from an untrusted source. And that's really the key. Sanitize everything from the client. We said that back on the first slide about SQL injection. And sanitizing in this case is essentially just escaping certain characters that could appear in the string. So by escaping the single quote with a secondary single quote, which is how Postgres, one of the ways Postgres sanitizes data, We've now turned this whole thing into just a string to search for in a certain field, and of course, it's not going to find any data, but it's not going to delete our invoices table also. And every backend has different sanitization rules that you need to follow. In our Mertech package, we have a sanitize function that we advise people to use on all of their SQL calls that will sanitize for whatever backend you're using, so that you don't have to worry about this sort of thing. You have to make sure you're using that everywhere, though. And in fact, this is a risk on Windows applications as well. If you have a filter in a Windows application, maybe using some of the new filtering that's in 18 even, you have these same sort of worries that come up there, and you need to sanitize what goes into that filter there. So you have to be very careful with this sort of stuff, but it's actually pretty easy to protect against if you just follow the rule to sanitize everything.
So,
go ahead.
Oliver, I have a comment from Chuck here. Chuck, you want to? He's pointing out some syntax error. After drop tables, if there is no semicolon, will this still run?
Yes, it will still run. Absolutely. You don't need a semicolon on the last statement at all. So that runs just fine. No problem there. So you need semicolons in between statements. You don't need them at the end for every database backend. And one of the things you can actually find very easily if you just do a couple of searches. Protecting against SQL injection attacks is one of the primary things that's done from the standpoint of penetration testing or pen testing. If you just do a search for your database backend, such as Oracle and SQL injection, most likely you're going to find various sites that are at the top of Google that are for pen testers that are cheat sheets. And those cheat sheets are going to list all the non-destructive SQL injection attacks that you can do. So this is something definitely that you should watch for, but like I said, it's not too difficult to protect against. Those are the four main areas that I wanted to go over. Now, there were a few other areas that we had mentioned in some of the information for this webinar related to business rules, session management, and third-party authentication. Realistically, we're going to actually have to come back to security again and hit some of those topics. This area of security is just so large. They're just really to give everything its fair share. This webinar would have just gone on too long. So I'm not actually going to address those. We're going to save those for a second security campfire. I don't know if that's going to be our next one or if we'll save that for a future one.
Oliver,
but I wanted to open this up to questions.
Yeah, Oliver, I have a question for you. Coming back to the SQL injection and SQL, what are the scenarios where how can somebody exploit this in a web application? So if you have a regular web application you've written, how will they get an opportunity to inject that SQL into your queries that you're sending back to the database?
Well, like I mentioned, I'll show you just where on an application something like this can come up. So let's go over here and we're just going to go to just one of our demo sites that we have up here. Let's see here. Oh, order entry. Oh, maybe they're working on this one right now. Okay, pull up a different one. Okay. Let's see if I can get the password for this one real quick. So the place where I see this happen the most is on filtering pages. So a lot of times uh, other applications won't have, um, for just doing data entry, they'll use, like for instance, this is a Ruby on Rails based application, and it's going to use their built-in mechanism, kind of like a data dictionary mechanism, to add a new record. But when you're filtering, such as on this screen here, um, if I do a filter like this on it, those sorts of filters a lot of times are running straight SQL calls. And so in these filters, on lists are where a lot of times people will choose to exploit them the most. I mean, there are other places as well, but this is a place that's, I think, the most common one nowadays. And there's a couple of reasons for that. One is that a lot of times the filters are just kind of shoved into the SQL call and may even be done after the fact, and so attention wasn't necessarily paid in that area. Because they're not updating records or things like that. Filters often will let you put anything in, so they don't have limitations on the client side, so you don't even have to work really to use the exploit in that way. And additionally, because they're set up to show the tables of data coming in, a lot of times you can alter the SQL call and access other things without any difficulty to it at all. So it can be really easy to do on a filtered list like this. So protecting against it, like I said, just requires that you sanitize your data.
What does that mean?
It means essentially what we did here, where we escaped the data. Where in this case we ran a sanitize function on it, and it saw that the data from the client had a quote in it, and so it escaped that quote and did a double quote for us. It's going to look for all of that for you and basically add those extra characters in. And various backends have different ways of dealing with it. For instance, Postgres has this really unique thing I think they call it dollar quoting, where essentially you can come up with your own close quote string that is randomly generated even for how you start and stop a string in a SQL call, and it makes it, if you've got that set up on your back end, you can make it so that even if someone has forgotten to sanitize something, it essentially still gets sanitized by the fact that a closing quote isn't what closes the string. Some random grouping of characters does it. No one's ever going to be able to figure out what random grouping of characters you used, because you can make an opening and closing string as long as you want. So there have been some novel approaches to this in the past, but pretty much every backend has built into their to one or more of their interfaces a sanitize call anyways. And like I said, for our driver, we expose a sanitize call that works across all of the database drivers.
Does anybody else have any question? Just please raise your hand and I'll unmute you and you can interact directly with Oliver. So in the context of Dataflex applications, Oliver, what are some of the other important security aspects that developers don't pay attention to?
Well, I think the biggest one that really I wanted to be able to spend some time on is session management. Session management is one of those items where a lot of times the easiest way is to use something that is already out there for it, and session management is a complex topic, and just using something that's out there already has risks associated with it, that where basically what happens normally is that you have a mismatch between your security requirements and the security requirements that are enforced by the session management system. And so a lot of times session management requires that you actually create a matrix of how your application needs to work against, if you are going to use some prepackaged one, and make sure that they match each other in all the same places, because oftentimes they don't. And of course we've seen security risks and basically bugs in session management systems also that cause problems.
So Oliver, Mark has a question. Mark Powers. Mark, go ahead.
Yeah, Oliver, what creates the salt key?
So for generating a salt, the way I tend to do it is to use there's a security package. We have sort of our own version of it, but there's a security package for Dataflex that calls some of the Windows API calls, and there are some Windows API calls to generate random data for you. And so essentially we will call those and make sure that the data return fits within a character set that we can store in the database and some things like that. But we will use the operating system's randomizer to generate salt data for us. You could, of course, use a Dataflex random function, but I don't really have any sort of information on exactly how the Dataflex random function, internally works, how random it is in comparison to what the operating system provides. So we use that to generate our salts.
Thank you.
So,
question from Chuck here.
Okay. Can you use a GUID for the salt? From Chuck. Yeah, absolutely. You can use a GUID. There's no reason you can't do that at all. There's no problem with that. Absolutely. When you do use a GUID for a salt, you want to make sure that you're using the right version of a GUID, since some GUIDs have items in them that are easily guessable related to timestamping. So you want to make sure you're using, I think it's called like a version 4 GUID is what you want to focus on. The other versions, it's not that one's better than the other, they're just for different use cases. So make sure that when you get your GUID, you're using one that's based on a fully randomized generation algorithm rather than like a MAC and timestamp or something like that. So the only other issue with GUID to be aware of for your salt is that is kind of a long salt, but for fields nowadays it doesn't much matter, so I wouldn't worry about it.
So Oliver, one thought that comes to my mind is that if you're doing a lot of stuff on the server side, like I think Dataflex VDF, Dataflex 18.1, would some of these security vulnerabilities would be mitigated because a lot of things are being done on the server side?
Well, not really. I mean, there are some things that are mitigated. The SQL injection, if you're using constraint filters that are actually using some of the new stuff in 18.1 and 18, then that's not. Then you still have the issue entirely. I think that some of these still stand. Certainly generation of passwords it still stands the way it is as well. You have the exact same password concerns no matter what you do, no matter what system you're using. So that item still stands. The session contamination issue, essentially that's going to come down to whether there are bugs in the framework you're using that have session contamination risks associated with them, and that's a topic all on its own. Is the framework you're using secure from that standpoint? Are there places where where state is left behind where it shouldn't be left behind? The more complex the framework, the more likely that there's going to be some issue just because of the inherent complexity of it. Chuck asked another question here. He asks, you probably won't name your field user.salt. Actually, I would name it user.salt. No problem at all with that name. So one of the things that I'm very adamant about is to I do not believe at all in security by obscurity. Riaz will tell you, I've mentioned this to him before. This is a true belief of mine. Obscuring something to make it less obvious what it is does more harm to the developers using it than it does provide you any level of protection. Obscuring something is in no form a method of securing it. So make it as absolutely obvious as possible what each field is and what you're doing with that field, and be dependent upon the algorithms and rules that you're following to provide your security. Don't be dependent upon hiding things to provide it.
So I have a question here from Richard Hogg. One second, Richard. Richard, you want to go ahead?
Richard, you want to go ahead?
Oliver.
Richard's.
Okay, I see his question here.
What type of field and length would you use for user.salt and user.hash?
So for the salt, a lot of times people are advising a minimum of a 12-digit salt. I've used the GUID way before also, like Chuck mentioned, and so in that case, if you're storing it as a string, I think it's like 38 bytes or something. On the hash, it depends on what hashing algorithm you're using. They all hash to different lengths. I think a PB what is it? PBDFK2, that one. The 256 version of it hashes to something like 80 characters. All the different hashing algorithms always hash to the same length. So essentially, if you decide on bcrypt or scrypt or the PBK DF2, have to look at the length they generate, and they're always going to generate the same length. So I don't know off the top of my head what the lengths are for all of those, but since they're always identical, you can just base it off of that. A lot of them are somewhere around 60 to 80 characters long. So this kind of leads to the question: how do you use some of these other ones in Dataflex? We've got I wrote an SHA-1 hash algorithm for Dataflex. I think there's an MD5 one out there, but these other ones, the ones I'm advising, aren't there. You either need to use a DLL for them, or find some other implementation to port over. I advise using a DLL for this. That's one of the advantages that some of the other systems have over Dataflex, to be honest. Some of these other hashes are just built into packages for other programming languages. In general, for Dataflex, though, you're going to need to find a DLL that implements these, and do a call that way to use them. As far as I know, bcrypt, scrypt, and PBKDF2 have no OS implementation in Windows, so there's nothing that's going to be baked into Windows 8 for that I know of. So it'll be a third-party DLL for sure, but there's quite a few of them out there that you can use.
Okay, I think we're a little bit over time. If anybody has, I don't see any questions here, so I think we're going to end it. Thank you, Oliver, again. Hope we were able to give you some information, some things to think about. And if you have interest in the security aspect, as Oliver mentioned, that we could potentially go on and then do another couple of sessions down the road, then please let us know, and we'll organize something. And if you're interested in participating as a panelist and talking about some of your experiences and share some of your security insights, you're more than welcome to join us next time. So just send us an email, and we'll organize one for you guys. Thank you all. We had a pretty good attendance. Oliver, getting a thank you from Roel Westhoff in Netherlands.
Oh, thank you.
Hope you enjoyed this and it was useful. And probably in the next 6 to 8 weeks, we'll have another Campfire session related to some other technology. So with that, we end. Oliver, thank you.
Thank you, guys.
Bye.
See you next time.